Right away. Right. Good morning, all. We'll start. How about the audio? Let me check from my end also. Oh, it's working fine, right? All right. Okay, it's working fine. Good morning again. We'll start. All right. Uh, Intensity levels. Right. Intensity levels. So first, I'll explain about the lesson and the significance of the lesson. Right. So when it comes to intensity levels is the last part of waves. So under waves and oscillations, the last part we have is intensity levels, right? After Doppler's effect. So when it comes to intensity levels, that is the smallest and the easiest part we have in waves, right? To be honest, that is the smallest and the easiest part we have in waves, right? And about the marking in the sense about the mark that you can score using intensity levels, it's like this. There is definite 1 MCQ. There's definite 1 MCQ, right? So that is the only definite mark we have, definite 1 MCQ out of 50. And this part can be linked to the essay questions, right? So usually, so therefore it will be linked to essays. Usually it is linked to essays, right? Even though the question is coming from, let's say, Doppler's effect, question 6, essay 1, essay 4, waves and oscillations, right? So there are links to intensity levels in those in such questions as well, right? So therefore, even though this is the only definite mark we have, right? Now, if I factor the essay parts as well, right? That is not a definite mark, but yet if you got a question, right? So there also you'll be getting around 1 to 2 marks, right? So that's the gravity of the lesson. That's the gravity of the lesson. So this is actually a small lesson. So therefore, now since the lesson is small, allocation of marks is also kind of comparatively kind of less because there is a small lesson, but definite 1 MCQ is coming. Definite 1 MCQ is coming, right? So you have to collect these marks one by one. No? You have to collect the marks one by one. Otherwise, you are not going to collect whole 100 marks at once, right? So that is a journey of 2.5 years of your life, right? So at the end, you are collecting 95 marks, 96, 100. So up to 100, that is how it is, right? So this is also another 1 mark along your journey. Got it? That's the idea. So if you haven't got the route yet, as I have mentioned here, you can put a WhatsApp message to this number and get the route, right? Okay. All right then. Then we'll start, right? We'll start. So you are on your vacation. You are on your vacation, and it's better that you are spending your vacation effectively, right? And if you have any questions, always you can use the YouTube live chat to put all your questions and get it clarified, right? So I can see it. I'm always looking at the chat. So simply what you can do is you can put all the doubts, all the questions you have to the YouTube chat. So I can see easily. All right then. Okay, we'll start. Give me 1 second to check the video again. Okay, it's perfectly fine. All right. All right, so it's working fine. Let's start then. Take down the heading intensity levels. Intensity levels. So, since we are covering the full lesson today itself just by the seminar, right? Stay in the seminar from the start to the end. We are starting from scratch, and I'm going to cover all the questions from 0 to 100. 0 to 100 means from A to Z, right? From scratch, from simple question to the advanced questions, right? So stay in the class from beginning to the end and secure this mark. So that's it. Secure the mark. Secure the mark. This one mark, one attainable mark you have for sure in the MCQ paper. One attainable mark. 1 mark, 1% from 100. 1 mark from 100. That's MCQ. No? All right then. So take down the heading as intensity levels. Intensity levels. All right. So before going to intensity levels, first let's see what intensity is. Right? First let's see what intensity is. Take down this subheading as intensity. 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 Right. So there's a general equation for intensity because there are different types of intensities we have throughout our syllabus. Right? Now this is the first point where you are starting to learn about intensity. And here what we have actually is about sound intensity because these under waves and oscillations. No? So therefore here what you have is about sound intensity. But in other coming up parts, there are more types of intensities you are going to see. So therefore first I will start with the general definition of intensity. Right? Otherwise I can explain what sound intensity is. Right? But before going to sound intensity, first we will see what general intensity is. Then you can easily link it to the other intensities like sound intensity, heat radiation intensity. Likewise, you can link it to anywhere once you need, right? Okay. For intensity, there is a general equation. The equation goes like this. We call the equation E equals ITA. E equals ITA. ITA for our is we usually call ITA, right? E equals ITA, where E is energy of incident waves, I intensity, T time, A perpendicular area, right? Perpendicular area or the exposed area. Now from this I'm going to subject I. See, subject I equals E over TA. Very simple. I equals E over TA. E over TA. So therefore intensity is defined as total energy of incident waves per unit time on unit perpendicular area is defined as intensity, right? See how easy it is. Okay, take down the equation and write up to here. Right, introduce these terms. Since you are new to the equation, introduce these terms. You anyway know. E, T, A. Introduce terms I intensity, I intensity, I intensity, E energy of waves, E energy of total energy. Write it as total energy. Total energy of waves. Total energy of waves. T time. T time. A perpendicular area. A perpendicular area. A perpendicular area. Perpendicular area. Right. Listen. Now in intensity, since any wave is if there are no any special conditions, since any wave is propagating in all 360 directions, all around directions, as the perpendicular area, in 95% of questions, what we are getting is the area of a sphere. Because if this is the sound source, now from this sound source, sound waves are emitting all around, right? As in a sphere. Therefore, for 95% of questions, we are going to use the area of a sphere here. So within brackets, write down this for your reference. Otherwise, that is not the introduction. Within brackets, write down for area, write down area of a sphere, area of a sphere, area of sphere, area of sphere. Right. Then as a next heading, write down definition of intensity. Definition of intensity. We are going to define this. Write down definition of intensity. Definition of intensity. Definition of intensity. Right. So I explain you the definition. Just focus on this and write down the subjected equation again under definition. I equals EOTA. Write this down again. Just by looking at this, we are going to define intensity. Just by looking at this. Because this is the equation of intensity. This is the equation of intensity. Equals ITA. So I is EOTA. Right? So write down the definition in red. Write down the definition in red. Total energy of incident waves. Total energy of incident waves. Total energy of incident waves on unit perpendicular area. On unit perpendicular area, we know always you have to make denominator terms 1. 1 means unit terms. Unit terms. On unit perpendicular area per unit time. On unit perpendicular area per unit time. Per unit time is defined as intensity. Is defined as intensity. Is defined as intensity. Okay, right. Now you got a small task. Find units and dimensions of intensity. Quickly. Find units and dimensions of intensity and you can put your answers to the chat. I need units and dimensions of intensity. Units and dimensions of intensity. Quickly. 1 minute. 1 minute. Quickly. Units and dimensions of intensity. Anyone who got answers? Anyone who got answers? Units. See, the equation is E over TA. E over TA. Right? But something important. E over T is a non-physical quantity. What is E over T? E over T as a whole term, E over T is a non-physical quantity. Energy over time is power. So therefore, as a standard unit, as a SI unit, for power, we can straight away use watts. So therefore, this whole thing is watts. And area is m squared. This is Wm minus 2 watts per square meter. Right? Dimensions of energy over dimensions of time, dimensions of area, dimensions of energy, ml squared t minus 2 over dimensions of time is t, dimensions of area l squared, these two cancels. Right? So what is coming? mt minus 3. mt minus 3. mt minus 3. right? It's easy. It's easy. So quickly you can do. Now you saw what intensity is, right? Now let's see what intensity of sound is, or what sound intensity is. As an next heading, write down definition of intensity of sound. Next heading, definition of intensity of sound. Definition of intensity of sound. Definition of intensity of sound. Definition of intensity of sound, right? So more or less the same thing. Listen, more or less the same thing, because intensity is E over T, Now, when it comes to sound waves, when we are going to specify that to sound waves, right? So you have to say that is the total energy of sound waves, incident sound waves. That's it, right? Same thing. Okay, mention in red. Mention the definition in red. Total energy of total energy of total energy of incident sound waves. Total energy of incident sound waves total energy of incident sound waves. Same thing, on unit perpendicular area. On unit perpendicular area. Same thing. On unit perpendicular area per unit time. On unit perpendicular area per unit time. On unit perpendicular area per unit time is defined as intensity of sound. Is defined as intensity of sound. Is defined as intensity of sound. Right. We are moving on next heading. As the next heading, write down dependence of intensity. Dependence. Dependence of intensity. Dependence of intensity. See, look at the board. Look at the board. If amplitude is A, intensity is dependent on the square of amplitude, right? And if frequency is F, intensity is depending on a square of frequency. And if distance is say R, distance is R, intensity is inverse proportional to R. So these three are called the dependence of intensity. So combining these three, look at here. If there are, multiple relationships with proportionate signs, right? You can take the multiplication as also as proportionate, right? That we discussed for the first time under units and dimensions, right? Under dimension analysis, the same idea. So I'm going to combine all. Then we can say I is proportional to a squared f squared over r squared, right? So these are the dependence of intensity. Okay, write down this way. Write down this way. If amplitude is capital A, if amplitude is capital A, if amplitude is capital A, comma, frequency symbol F and distance R. Frequency symbol F and distance R. Put a comma. Distance R, put a comma and take this down. Take this down. And label these equations as 1, 2, 3. I'll be referring these equations again in the future. Right? Label these three as 1, 2, 3. right? Listen, now if we have proportionality equations, we know we can apply the equation for two occasions and divide the equations. You can apply the equation for two occasions and divide. Something we usually do. So here also I'm going to do the same from 1, 2, 3. See, now if I do this from 1, look at the board. From 1, I can say, if I apply for two scenarios and divide, I1 over I2 equals A1 squared over A2 squared, isn't it? Similarly, from 2, you can say I1 over I2 equals, when proportionate equations are divided, we can write it as equal signs equals F1 squared over F2 squared. And from 3, I1 over I2 equals here R2 squared over R1 squared, because that is proportional to 1 over R squared, right? So therefore, by applying these equations for two scenarios, two instances, we can get these three as well. So highlight these three equations as well. Take it down and highlight like this. Take it down and highlight. So these are the equations you are going to deal with in the lesson. These are the equations you are going to deal with in the lesson. Okay, take it down. Right? Take it down. Okay, listen. Listen. Now we are going to move on to the intensity level. Now we were discussing about intensity up to this point, about intensity, right? Now we are going to go on to intensity levels. So before intensity levels, first thing is equation of intensity levels is a log equation. That's a log equation. So therefore, you have to know the basic log simplifications, right? Basic log simplifications in the sense, all these simplifications are O-level simplifications. Huh? All these log simplifications are O-level simplifications, right? To be on the safe side, I'm going to recall these log simplifications. Otherwise, all of you should know these simplifications because they are coming from O-levels, O-level logarithms. Okay, quickly let's see what log simplifications are needed here in intensity levels, right? For sure, you should know them, right? You should know probably, but if that is forgotten, you can remind, you can recall that again with this. See? Okay, see? Basic logs. Basic logs. O level logs. Right. Now, when you respond, you can use a YouTube live chat and respond. Right? Okay. Okay. See, the first thing, say log based in 1. What's the value? Log based in 1. Log based in 1 is 0. Right? 1 of any base is 0. Log 1 of any base is 0. Log based in 1 is 0. And log based in 10 equals 1. Right? So which means log base x equals 1. Right? Same idea. Same idea. And if you have a power like this, say log base x, x to the power n, log base x to the power n, right? So you can take this power to the front like this, n times log base x. But we know log base x is 1. This part is 1, no? So therefore this is n. This is n. Basic simplifications. Basic simplifications. And log multiplications. Say log base 10 x times y. This can be written as log base 10 x plus log base 10 y. Right? Very comparative for the division. Log base 10, let's say x over y. This can be written as log base 10 x minus log base 10 y. Right? They works both ways. Right? So if you have this, you can write this way. If you have something like this, you can write this way as well. Right? Then the other thing is about subjecting. About subjecting. Now, as an example, if I write this using numbers, let's say log base 2, 8. So this answer is 3 now. Log base 2, 8 is 3. If you subject 8, right? How you subject this as, see, how you subject this as this. 2 to the power 3 equals 8. 2 to the power 3 equals 8. Or rather, 8 equals 2 to the power 3. 8 equals 2 to the power 3. Now, if you have something like this, see, log base e to the power x equals y. If you need to subject x, right? X is e to the power y. X is e to the power y. So what basically happens is, this base goes as taking this value here as the power. See, so when you subject this, can you see the pattern? 2 to the power 3 equals 8. E to the power y equals x. Right? So in also you are doing subjecting. Right? Same thing. Same thing. Right? So these are the basic log simplifications needed here. Right? So if you have no idea about logs, I don't think you have no idea because these are all oral simplifications. Right? If you need to recall, you can take this down as a note before moving on to the next part quickly. And if there's any questions, you can ask. If any questions, you can ask quickly and clarify. All good. Any questions so far? right? O-level log simplifications, huh? Just recall it. Just recall it. O-level simplifications. And especially subjecting something from log, this is kind of important. Subjecting the co of log x is e to the power y. Always this base is taking this thing to the power e to the power y. All right. Let's move on. As the next heading, write down intensity level. Intensity level. Next heading. Intensity level. Intensity level. Intensity level. Within brackets, beta. Within brackets, beta. Right? Beta. Since intensity levels are denoted using beta, this is also called beta functions. This is also called beta functions. Beta functions. Right? So just know the word. This is also called beta functions. So if needed, I can mention. Right? This is also called beta functions. Beta functions. Okay. See? Right, listen. This is something like this. Intensity level is a value which is defined, value which is obtained based on intensity. Right? I'll explain in the coming parts what's the reason to define two values as to introduce two parameters as intensity and intensity level, right? That you will see in the coming part, right? For now, just know that intensity level is a value which is obtained using intensity, right? So it actually represents it's representing deriving the degree of the amount of intensity a particular space has, right? So first write down below this. Intensity level is intensity level is a value determined. Intensity level is a value determined. Intensity level is a value determined with respect to threshold of hearing. Threshold. With respect to threshold of hearing of human. With respect to threshold of hearing of human. With respect to threshold of hearing of human. Right? With respect to threshold of hearing of human. Listen, what is threshold of hearing? That is the first thing. Threshold of hearing. We call I note. We denote this by I note usually. Right? Listen, threshold of hearing means as humans, we also have minimum and maximum levels of intensity that we could hear. Right? As humans, we have minimum and maximum levels of intensities we could hear. Right? That minimum intensity a human ear can hear is called threshold intensity. Right? That is the threshold of hearing. That is what is we call threshold of hearing. Right? So minimum intensity that we could hear, anything that is below that we don't hear. Right? So therefore there's a range. Now a comparative one is, the frequency range of human ear from 20 hertz to 20 kilohertz or 20 to 20,000 hertz. Similarly, for intensity also we have a threshold and we have a range. Threshold of hearing means the minimum intensity that a human ear can hear. Right? Okay. Mention this in red. Mention in red with an asterisk mark. mentioned in red with an asterisk mark. Threshold of hearing, threshold of hearing, threshold of hearing within brackets I naught, threshold of hearing within brackets I naught, like this. Threshold of hearing within brackets I naught is the minimum, is the minimum, is the minimum intensity that could be heard, is the minimum intensity that could be heard, that could be heard by human ear, 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 right? Okay, look at here. So this is the value. This value is a constant value for a healthy person. No? This value is a constant value for a healthy human, a healthy person. I note is 10 to the power minus 12 Wm minus 2, right? So you have to know this value. You have to know this value. Sometimes this is given with the question, sometimes not. So you have to know this value, and this is a constant. This is a constant. Take this down. Take this down. That is a constant. That is a constant for a human. No? Now, from animal to animal, it changes. From human to dogs to cats to, so likewise it changes. For humans, this is the value that is a constant for a healthy person, right? Take it down. Take it down. We have very few theories here in intensity levels, so grab everything from the start, then you can easily do the coming up questions. Still, if there's anyone who didn't get the route, you can put a message to this number and get the route, right? So get ready because we are going to start the questions soon after. Okay, as the next heading, write down equation of intensity level. Equation of intensity level. Write down equation of intensity level. Equation of intensity level. Equation of intensity level. Okay. See, now you don't have to prove these equations. You just need to use the equations only. Right? This is the equation of intensity level. Look at the board. Beta equals 10 log base 10 I over I naught. Beta equals 10 log base 10 I over I naught. This is the equation of intensity level. Right? Intensity and intensity level are two different things. No? This is the equation of intensity level. Where beta is, we are going to define them. Where beta is intensity level, I is intensity, and I naught is threshold of hearing. I naught is threshold of hearing. Right. Take this down. Take down the equation. Take it down. Introduce terms beta intensity level. Introduce terms beta intensity level. Intensity level. I intensity. I intensity. I naught threshold of hearing. 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 threshold of hearing. Within brackets, again you can mention the value 10 to the power minus 12 Wm minus 2. 10 to the power minus 12 Wm minus 2. Right. Listen. The unit of intensity level is called decibels. The reason is that is actually coming as a honored unit, honored unit for the founding scientist, right? So therefore, it is defined as denoted as decibels. This is how decibels are written. This is the word, decibel. Decibels are written as simple D, capital B. Decibel, right? Decibel. Write down below with a red pen. Write down below with a red pen. Write down units of beta. Units of beta intensity level. Units of beta intensity level. Units of beta is decibels. 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 Within bracket, simple D, capital B. Right? Simple D, capital B. Decibels. Simple D, capital B. As I mentioned in the class during the vacation, we are going to conduct few question discussions as well, right? So stay connected and keep in touch in the channels and groups. Then you can get all updates when the dates are fixed through the channels and groups, right? So probably question discussions are also going to happen, right? Okay. So I know you are already writing questions in the paper class, but yet my plan is to conduct few more question discussions, and most importantly, the waves practical seminar, right? So that is the main thing that is coming up. Waves practical seminar, since waves are finished in the class, waves are completed in the class. Next practical seminars coming up are waves practical seminar and optics practical seminar, right? So stay connected for all the updates. Since you are also kind of available during the vacation, I'm going to utilize few hours, some more hours for those sessions. All right, finished. Then look at here. Look at the board. Now, if I do something like this, now this equation is like the variables in the equation are I and beta. Equations, variables in the equation are I and beta. When I changes, beta changes. I note is a constant. When I changes, beta changes. So therefore, I'm going to apply this equation for two given scenarios. Look at here. I'm going to apply the equation for two given scenarios. Now this is the equation. Beta equals 10 log base 10 I over I naught. If I am to use this for two scenarios, say scenario 1 and scenario 2, right? For scenario 1, beta equals, say beta 1 equals 10 log base 10 for scenario 1 respective intensity is, let's say I1, but I naught is a constant, so I1 over I naught. For scenario 2, beta 2 equals 10 log base 10, say respective intensity is I2 over I naught, right? So we know I can subtract these two equations. See what's happening if I subtract these two. Say this is equation 1 and this is equation 2, and I'm going to get the subtraction here 1 minus 2. 1 minus 2. See what's happening. Beta 1 minus beta 2. Beta 1 minus beta 2. Right? Equals 10 log base 10 I1 over I naught minus 10 log base 10 I2 over I naught. You can see this 10 is common. So I'm going to take it out. Beta 1 minus beta 2. Take that 10 out. Once 10 is out, log base 10 I1 over I naught minus here log base 10 I2 over I naught, right? A log subtraction, log subtraction can be written as log division. Log subtraction can be written as log division. I gave that in the note, right? In the recalling part of the logarithms. If you have a division, you can write it as a subtraction. So if you have a subtraction, you can do the opposite. See, now what happens is then beta 1 minus beta 2 can be written as 10. Now this is a division, no? Then log base 10, I1 over I naught divided by this part, which means multiplication with the reciprocal, no? So that is I naught over I2. Now you can see I naught cancels. And we are getting this equation as beta 1 minus beta 2 equals 10 log base 10. Here only I1 over I2 remains, I1 over I2. Right? So we are getting this equation as this. And we call this a delta beta equation. We call this a delta beta equation because we can also write this equation as delta beta. You can also write this equation as delta beta. Difference of beta equals 10 log base 10 I1 over I2. Right? So you can highlight both. So this is called delta beta equation. Right? Listen, the application of this equation is like if you have more than one scenarios, right? Simply if you have two scenarios, without using the general equation like this, directly you are going to apply, directly we are going to apply this delta beta equation for the ease of simplification, right? So therefore, delta beta equations are for more than two scenarios, when you have more than two scenarios, right? Okay, start from here and prove up to this point. Ask if there are any questions. Understand the steps and take it down. Right? Basic log simplifications. Finished? Right. When you apply this equation, this is how we use these values. For beta 1, for this value, the reason is this. Listen, the reason is this. There are no negatives for logs. There are no negative values in logs. Right? So therefore, we have to make sure that you don't get any negative values because logs are not defined for negative values in maths. Right? So therefore, For beta 1, always you have to use the higher value. For beta 1, always the higher value. And for beta 2, lower value. Beta 2, lower value. And from I1, I2 also, for I1, you have to use, let me label here, for I1, you have to use the higher value. And for I2, lower value. Right? So you can mention that as well. So that is how you should use this equation. Otherwise, you will get negative values. There are no negatives for logs. Okay? Like this, higher, lower, higher, lower. Right? Very simple. Then below that, write down in red, mention in red. Use delta beta equation. Use delta beta equations. Use delta beta equations when two scenarios are given. Use delta beta equations when two scenarios are given. Use delta beta equations when two scenarios are given. When two scenarios are given. All right. See. See. We can do something like this as well by going an extra mile. See. So we know the dependence of, the dependence of amplitude, frequency, and distance. Right? Now I'm going to connect this one with the previous equations you got. Right? From 1, 2, and 3, you got 3 equations now using amplitude and frequency and distance. I'm going to connect it with this. See, furthermore, what you can do is you can rewrite this equation by using what? Amplitude. Right? So there you have proved that using amplitude, I1 over I2 equals A1 squared over A2 squared. No, same thing. I'm going to connect here. Look at here. Now, in the same equation, instead of I1 over I2, we can write this in terms of amplitude. Same equation. Instead of I1 over I2, we can write this in terms of amplitude. See what happens? Then beta 1 minus beta 2. Beta 1 minus beta 2 equals 10 log base 10. Instead of I1 over I2, I can write A1 squared over A2 squared. No? Right? Now from this square is common. You can take it out. Beta 1 minus beta 2 equals 10 log base 10. How about this? A1 over A2, whole thing squared, no change. Whole thing squared, no change. So in the log simplifications I discussed, if you have a power, that power can be taken to the front. That power can be taken to the front. So therefore, this can be written as beta 1 minus beta 2 equals 10 times 2. Power is taken to the front. Like this, 10 times 2 log base 10 A1 over A2. Right? So final equation, beta 1 minus beta 2 equals 20 log base 10 A1 over A2. Right? So this is what happens in terms of amplitude. This is what happens in terms of amplitude. But if amplitude is given, you can directly use these delta beta equations using amplitude. Right? Similarly, I'm going to do the same for remaining two as well. Since I showed all the steps here, I'm not going to show these same steps again in the next one. Right? So if needed, you can mention the steps if you need to mention steps. These are the basic steps, and the same steps will be used in the other two as well. Second one is using frequency. Now, if you write this by using frequency, this is what happens. By using frequency, what you are getting is beta 1 minus beta 2 by using frequency. Beta 1 minus beta 2, do the same. 20 log base 10 f1 over f2 by using frequency. And then we can do the same by using distance. And then you can do the same by using distance like this. By using distance, beta 1 minus beta 2, 20 log base 10, but R2 over R1, right? So this is very popularly used when it comes to questions. This equation is very important. Very popularly used when it comes to questions, right? One of the common mistakes students do is, right, by mistakenly, you are writing beta 1 minus beta 2 equals 10 log as 10 log, even though there is a distance equation. And if there is a MCQ, for sure, the answer coming with 10 log is also there, right? But the equation is 20 log. So this is very popularly used among these three equations when it comes to questions, right? So keep that in mind. For amplitude, frequency, and distance, that comes as a 20 log, not 10 log. Take it down starting from here. Start from here and take it down all the way up to this point. Can you explain the amplitude again? This is the same thing I discussed at the beginning. The relationship between I and A, the dependence of intensity, right? So I referred to that point. Since I have proved the equation there, I have directly taken the equation and plugged the value here, right? So if you are not there at the beginning, you can go back and see. You can rewind the live and see. I use the direct equation I proved before. Okay, clear. Good. Good, good. Okay, finished? Right. Okay. Right. From here, all theory parts of intensity levels is over. Right. From here, all theory parts are over. I told you this is a very small lesson, small part, small lesson. Right. Now, before moving on to the questions, sums, I'll again quickly summarize what you have learned so far. Right. I'm going to summarize this quickly. See, I'm going to summarize all the equations you learned quickly before moving on to sums. See, summary. See, so first you learned the general equation of beta. Beta equals 10 log base 10 I over I naught. Right? Where we know I naught is 10 to the power minus 12 Wm minus 2. Right? Then delta beta equations. First delta beta equation, general equation of delta beta, beta 1 minus beta 2 equals 10 log base 10 I1 over I2. Right? And then the other forms of delta beta equation, the other forms, beta 1 minus beta 2 equals, right, 20 log base 10 R2 over R1 using distance, and beta 1 minus beta 2 equals 20 log base 10 F1 over F2 using frequency, and beta 1 minus beta 2 equals 20 log base 10 A1 over A2 using amplitude, right? This equation is only for one scenario, right? This is for only one scenario, right? And all these equations are for two different scenarios, right? So this is a whole summary of what you have learned so far, right? Take it down quickly. This is a whole summary of what you have learned so far. Right? Okay, finished? Finished? Okay. That's it. So let's start off with questions. Go to page 2, question 1 on tute. Page 2, question 1. Go to page 2, question 1 on tute. Page 2, question 1 on tute. Question 1. Okay. Read it. Threshold of hearing of human is 10 to the power minus 12 Wm minus 2. Determine corresponding intensity level. Determine respective intensity level, corresponding intensity level. Right? First, read the question and understand how many scenarios are given. If there is only one scenario, go with the general equation of intensity level. If there are two different scenarios, you have four choices. Then, based on what is given, whether it's intensity or distance or frequency or amplitude, you can pick any equation from this list of four. Right? Okay, now only one scenario is given no, for question 1. So, directly apply the general equation like this. Beta equals 10 log base 10 I over I naught, right? I over I naught. Now, threshold of hearing of human is 10 to the minus 12, and the corresponding intensity level is asked. If you need to find the intensity level, put the corresponding intensity as I, right? So, therefore, see what happens here when we do so. 10 log base 10. Now, I is also threshold 10 to the minus 12, and I naught is anyway 10 to the minus 12. That is the threshold of hearing constant. These two cancels. These two cancels. What happens? Beta equals 10 log base 10 1. Right? I proved before. This part equals 0. So therefore, beta equals 0 decibels. Beta equals 0 decibels. What if? So likewise, if you have only one scenario, just one scenario, apply the general equation. Right? If not, you can pick from the delta beta equations. Right? It's clear now? Take it down. Okay, so if you have finished it, try question 2. Try question 2. A similar time. Try question 2. Try question 2 and send me your answers to the chat, live chat. Send me your answers to the live chat. It's only 9 months here onwards for your exam. Now 25 batch has already started their exam yesterday. Right? They had the PO paper. But I hope you have seen the paper. Right? So just by parroting maths, you can't tackle the questions there because there are good thinking parts in the PO paper. Right? So in physics also, we expect to have such cases. Right? So therefore, just by parroting something out, the modern exam pattern is not going to let you go just by parroting something out. So therefore, always you have to understand theories, you have to realize theories, right? Realize concepts. Then definitely you would go through. Otherwise, if you parrot something, we'll get stuck at the question, right? In physics, there is that nature is there, that nature of questions are there more than maths in physics, more thinkings, right? So today, the bio second paper is ongoing now, right? I mean, it's today bio second paper ongoing, and tomorrow it's applied maths paper. By Friday, physics first. By next Monday, physics second. Next Wednesday, chemistry first. Next Friday, chemistry second, and the whole story is finished, right? For you also, you are going to face the same just in 9 months. Just in 9 months, right? Actually, in less than 9 months, right? Around 8, 10 half months. Utilize this time and engage with all the things and put your fullest effort during this period of time, so you can change the result, you can change the grades that you are going to get from F to A even during the period if you wisely use the time period. You use this time period wisely, right? So that's all about the way you work. Keep that in mind. Study hard, work hard. What about question 2? Any answers? So use it wisely. Any answers for question 2? Quickly. Anyone? Hafil, 120 decibels. Good. That is correct. Right? So even though the chat is live, don't hesitate to put your answers because you should be confident enough about your answer because you are the one who got that value. So therefore, don't hesitate to put your answers to the live chat. That is totally fine. 120 is correct. Good. It is correct. Good. See, question 2. Threshold of pain of human is 1 WM minus 2. Right? I explained what threshold of hearing is. Threshold of hearing was the minimum intensity a human ear could hear. No? Threshold of pain means the maximum intensity a human ear can hear without paining the ear, without having any pain in the ear, right? Without having any pain in the ear. That is called threshold of pain. So basically, that's the maximum intensity we could hear, right? 1. Determine corresponding intensity level. Same thing. Beta equals 10 log base 10 I over I naught, right? So beta equals 10 log base 10. Now I is 1. I naught is a constant 10 to the power minus 12. So you can take this to the numerator and simplify. 10 log base 10, 1 over 10 to the power minus 12 is 10 to the power 12. Right? You can take this index to the front. Then 10 times 12. Log base 10, 10. Log base 10, 10 is 1. So therefore, beta equals 120 decibels. 120 decibels. Very easy, very straightforward. Very easy and very straightforward. Good. Mention this point below. Mention this point below the question in red. Mention this point below the question in red. Threshold of pain is. Threshold of pain is. Threshold of pain is. Threshold of pain is the maximum intensity. Threshold of pain is the maximum intensity. Threshold of pain is the maximum intensity. A human ear could hear. A human ear could hear without having any pain. Without having any pain in the ear. Without having any pain in the ear. Without having any pain in the ear. Right. Now, if I summarize these values quickly about the human ear, see, these are the values for the human ear based on the frequency. Now, you know about frequency already. Look at here, frequency, intensity, and we just found intensity level. Right? So, these are the values you should know. Right? You should know all these values. So here I'll be mentioning the minimum and this is the maximum. Right? Minimum frequency is 20 hertz. No? Maximum frequency is 20 kilohertz. 20 kilohertz. Minimum intensity 10 to the power minus 12. WM minus 2. Maximum intensity is just 1. 1 WM minus 2. Minimum intensity level 0 decibels. Maximum intensity level 120 decibels. 120 decibels. Right? Write it down as well. Right? You should know these values about human ear. About human ear. Right? Therefore, you should have an idea about these values, right? You should have an idea about these values, right? Especially intensity levels, right? Now, listen, the practical scenario, the practical usage of intensity levels is like this, right? So, if you have noticed, there is a value mentioned in decibels in any kind of a sound source you are using, right? Now, as a simple example, if you are using, let's say, headphones, if you are using headphones, in the box itself, you can see a value is mentioned as the intensity level, right? The idea is this. Now, if you are hearing an intensity level which is greater than 120 decibels for a longer period, like 6 months daily, 1 year daily, so definitely your ear is going to be defective after that period, right? So therefore, this is the safe range we can hear, right? You should know these values. You should know these values. In some phones also, decibel warnings are coming. Decibel warnings means intensity level warnings are coming. And in some phones, those intensity levels, exposure to intensity is monitored, right? So therefore, you should know this. That is the literacy you should have by learning this lesson here, right? That is the literacy I expect to you to have by learning this here. If you are purchasing a buffle, let's say you are purchasing a speaker, a buffle for your home or something like that, then at least check what these decibel values are, right? So even though our threshold of pain is 120, that doesn't mean we don't hear sounds beyond 120. We hear, but there's a possibility of being defective. I mean, getting a defect for the ear if you expose to the sound in a long-term basis, right? The safe limit is this. So that is why the defined maximum threshold of pain is 1, and corresponding intensity level is 120. So just know that if you are using an iPhone, right? If you are not currently using, also if you use an iPhone in the future, right? In iPhones, if you are exceeding these levels, even warnings are coming, right? Why? That is because the users have, right? They think that the users have the enough literacy to understand what it says, right? If you are using Apple devices, that's there. Even in Apple watches, those warnings are coming, right? If you are in a high sound environment, as a wedding or something like that, even if it exceeds 120, it comes, right? The advice is to wear earplugs. You have seen earplugs, no? Earplugs. Wear earplugs if you are exposing to more than 120 decibels intensity level for a longer period, right? Hearing just once for 5 minutes is not going to impact, but if you expose to a longer period of time, that impacts, right? So you should know these things. You should know these things, right? So in some other phones also, I think these things are monitored, right? The only thing is you should know about it. Otherwise, if you don't know what is monitored in decibels, right, then you don't know what it is given, what's there. No. So in iPhones under health tab, you can see this. See, where? Uh, can you see this? It's visible, right? Can you see it says my exposure is 66 decibels. Can you see? Can you see? It says my exposure is 66 decibels. Here. It says my exposure is 66 decibels. Right. So that is the last 7 days. So in last 7 days, I have exposed to 66 decibels when I'm using headphones, right? So in iPhones, if it exceeds 100 decibels, as I can remember, a warning is coming when we exceed 100 decibels, but our limit is at 120. So here for the safety, you expose 100 decibels, a warning comes as you are exposing to high loudness environment, something like that. So you could experience hearing disabilities or something like that, blah, 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 something is coming, right? So likewise, you should know them. You should know them, right? Not just in the devices, listen, not just in the devices. So when you purchase something, when you purchase a sound device, something like an earphone, a headphone, muffle, speakers, right? You should be able to check out these values. That's the purpose. That's the purpose. Correct. So that's the learning behind learning these intensity levels in physics, right? All right. So spread these things among other students as well, right? Because these are very important when it comes to day-to-day lives, right? Not just for the sake of doing the question. These things are very important for the day-to-day lives, right? When you are dealing in day-to-day lives, right? So especially you can spread these things among the other stream students like arts, commerce, common stream students, because you are the only one who are learning this under science stream under physics, right? So spread the news. But sometimes even if you have learned physics, there are some students who don't know the exact the practicability of intensity levels. This is a practicability, right? You will see these things in your day-to-day lives in the future, right? That is why you should know. So at that point, you should be able to recall and remember what intensity levels are and what these ranges are, right? That's a purpose. That's a purpose. Okay, that's enough. Go to question 3. Question 3. Any answers? Question 3. A sound of intensity 10 to the minus 8 Wm minus 2 is emitted by a horn. Determine intensity level of sound. Intensity level of this sound. Any answers? Any answers? Question 3. A sound of intensity 10 to the minus 8 is emitted by a horn. Determine the intensity level. How many scenarios? Only one. Only one. Then go to the general equation. Mostly 40. Mizuki 40. Hafil 40. Okay, let's see. Good. It's good that you are trying. Beta equals 10 log base 10 I over I naught. Right? 10 log base 10 given intensity is 10 to the power minus 8. 10 to the power minus 8 over I naught 10 to the power minus 12. Right? Simplify this. Beta equals 10 log base 10, take it to the numerator, then 10 to the power plus 12. Plus 12 minus 8 means 10 to the power 4. We can take the index to the front. Then 10 times 4 log base 10, 10. This is 1. Right? Beta equals 40 decibels. See how easy this is? Equals 40 decibels. Right? Very easy. Very easy. Question 4. Go to question 4. Intensity level heard by a listener when there is, it should be 1B. Correct it as 1B. 1B in a beehive. Correct it as 1B. Cut off AQ. It should be 1B. 1B. Correct it as 1B. Intensity level heard by a listener when there is 1B in a beehive is 60 decibels. And intensity level of 100 decibels is heard when all bees are in beehive. Right? You know what the beehive is, right? Beehive. The place, the home of bees, beehive. How many bees are in the beehive? Right. I will give you a hint, then you can try. If intensity of one bee is I, right? If you have identical sources, intensity of 2 bees can be written as 2i. Intensity of 10 bees can be written as 10i. Intensity of 1000 bees can be written as 1000i. Intensity of n number of bees can be written as ni. Right? When you deal with identical sources. Keep that in mind and give it a try. Question 4. How many scenarios now? How many scenarios now? 2 scenarios. Huh? 2 scenarios. Because 1B and all bees. 1B and all bees. 2 scenarios. So directly apply a delta beta equation. Direct delta beta equation. Beta 1 minus beta 2 equals 10 log base 10 I1 over I2. Right? Beta 1 minus beta 2. Higher value 100 decibels. When all bees are here, 100 minus 60. 10 log base 10. Right. So I'm going to assume this way. Listen. I'm going to assume this way. I'm going to assume intensity of 1B as I. Intensity of 1B as I. And there are simple n number of bees are in the beehive. Right? Then 100 decibels is heard when all bees are in the beehive. You know, then there is Ni. That should be Ni. Ni. When 1B is here, 60, that is I. Right? Beta 1 minus beta 2. The corresponding value of beta 1 should be here, I1. Beta 2 should be here, I2. Right? Right? Higher value, lower value. I2, I cancels. Simplify. 40 equals 10 log base 10 n. 10 log base 10 n. Any answers? Anyone? Not yet. No answers yet. No answers yet. What do you say? Subject n. I discussed about subject in logs. Subject n. This 0 cancels. So final value 4 equals log base 10 n. Subject n. N equals 10 to the power 4. Right? Which means there are 10,000 bees in the beehive. There are 10,000 bees in the beehive. Right? 10 to the power 4. 10,000 bees in the beehive. What a possible value? 10,000 bees in the beehive. Right? Okay, mention these points in red below the question with an asterisk mark. Mention these points in red. First point, if intensity of one source is I, if intensity of one source is capital I, if intensity of one source is capital I, then intensity of simple n number of identical sources, intensity of simple n number of identical sources is given by ni, is given by ni, is given by ni, is given by ni. Okay, listen again. Now, even though that argument is possible in intensity, you can't do it for intensity level. La? See, this is the example. Now, when 1B is there, the decibel level was 60, intensity level was 60. When 10,000 Bs are there, that is not going to be 10,000 into 60, that is still 100. So, therefore, you can't assume that as a ratio, since there is a log function, that is important. For intensity, that is fine because intensity is not a log function. But for intensity level, you can't do this. You can't do it. Right? Intensity level should be calculated using the equation. Right? You can't say when there's 1B, if 60 decibels are emitted, when there are 2Bs, it is going to be 120 decibels. No, never. But intensity, that is correct. Okay, mention the other point in red. Next point in red. Mention the next point in red. Keep using red. Since intensity level is a log function, 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 log function, it's not directly proportional. It is not directly proportional. It is not directly proportional with number of sources. It is not directly proportional with number of sources. Okay, now try question 5. Similar type. Try question 5 quickly. Question 5. Question 5. Try question 5. Send me your answers. Send me your answers. Put your answers to the live chat. You can put your answers to the live chat. Question 5. Intensity level on human ear when a violin is played is 40 decibels. When a violin is played is 40. How many identical violins should be played in order to hear an intensity level of 60 decibels? Okay, same type. What's the answer? Mosadi, 100. Good. Very good. Very good. 100. Correct. Easy now. See, first thing you should understand is there are two scenarios. One violin and the next scenario when 100 decibels, when 60 decibels are heard. Right, two scenarios. So directly apply a delta beta equation. Beta 1 minus beta 2 equals 10 log base 10 I1 over I2. Beta 1 is 60, beta 2 40, 10 log base 10. Say number of violins are n, then ni or y. Same thing, I to I cancels. This is 20. 20 equals log base 10 n. Log base 10 n. 20 equals log base 10 n. Sorry, 10 log base 10 n. And 0 to 0 cancels. So finally 2 equals log base 10 n. Subject n. N is 10 to the power 2. So n is 100 violins. 100 violins. 100 violins. Clear? Go to question 6. Go to question 6. See how easy these questions are. Then I'll show you the past paper questions as well. Right? How easy the questions are. Very much easier. Right? This is one of the most gettable marks you have in your exam. Huh? This is one of the most gettable marks you have. Right? For sure you can get this. Easiest path we have. Easiest path. Okay, question 6. Any answers? Question 6, any answers? Anyone? What is the difference in intensity levels of intensities 10 to the power minus 4 and 10 to the power minus 8? A field in 40. A field 40. 40. Let's see. Others? So write quickly. I'm giving you a like a little bit of a time for the time purpose, right? Otherwise, I could do at once. Just try and try to get your answer before the discussion. These are very easier questions, right? Once you do the question, it takes like 10 seconds, 15 seconds to get the answer. Very easy. A field 40. Okay, now the time is enough. Let's see. Difference between 10 to the minus 5 minus 8. No. Then directly apply a delta beta equation again. Difference between two scenarios. So two scenarios. Right? Apply delta beta equation again. Right? I'll apply it as delta beta now. Delta beta equals 10 log base 10 I1 over I2. Right? Delta beta equals 10 log base 10. What is the higher value? Higher value is 10 to the minus 4. Higher value is 10 to the minus 4. Lower value 10 to the minus 8. Simplify. Delta beta equals 10 log base 10. When this comes to the top numerator, 10 to the power plus 8, then 10 to the power 4 remains. Right? Simplify. Delta beta equals, you can take this index to the front. Right? Then 10 times 4 log base 10, 10. This is 1. So delta beta equals 40 decibels. 40 decibels. 40 is correct. 40 decibels. Yes, 40 is correct. Go to question 7. Question 7. 40. Mostly. Good, good. Very good. Go to question 7. 7. An intensity level of 20 decibels is produced on a listener when one machine operated. Determine intensity level produced when such 20 machines are operated. A hint is given. The hint is given log base 10 2 is 0.3. Right? If a hint is given, for sure you should use and you have to use the given hint when you are reaching the answer. Right? So in physics, one of the worst things that that could ever happen is getting the correct answer without using the given hint, right? Which means your steps are wrong, right? If that happens, because in physics, usually hints are given in some questions, right? So if you got the correct answer without using the hint, which means for sure your steps are wrong. You have got the correct answer because of multiple mistakes. It can be. For sure, your steps are wrong. Right? So that is why hint is given. If you follow the proper way, you have to use the hint. Right? All right. What about question 7? Start 7. Any answers? Question 7. Question 7. Any answers? 33 decibels. Good. Very good. Superb. 33 decibels. Superb. Seven. Again, two scenarios. To apply a delta beta equation, beta 1 minus beta 2 equals 10 log base 10 I1 over I2. Right? When 20 machines are operated, so that is going to be the higher intensity level. So, which means we are going to find beta 1. We are going to find beta 1. Beta 1 minus lower level is 20. 20 when one machine, right? 20. Then 10 log base 10, 20 machines, no? So let's assume intensity level of intensity of one machine as I, then 20 I over I. Intensity of one machine is I to I cancels. So beta 1 minus 20 equals 10 log base 10, 20. 10 log base 10, 20. Now look at the hint. Look at the hint given. Log base 10, 2 is given. Then try to rewrite this, rearrange this using log base 10, 2. See, log simplifications. I explained before. Beta 1 minus 20 equals 10 log, right? Base 10, you can write this as 10 times 2, no? No problem. 10 times 2. Log multiplication can be written as an addition. Then beta 1 minus 20 equals, I'm going to take this 10 out, and log multiplication is an addition, no? Then log 10, 10 plus log base 10, 2. This is a known value. Log base 10, 10 is 1. And log base 10, 2 is given 0.3. Right? Then beta 1 minus 20 equals 10 times 1.3. Which means beta 1 minus 20 equals 13. Beta 1 equals 33 decibels. Good. 33 decibels. It seems only one has got the correct answer. I can see the correct answer from only one in the chat. Right? So rearrange it. Rearrange it. Go another extra step, extra mile from here. Right? Now, if it was a simplifiable one, I know for sure you know you do now. Right? Now, rearrange it based on the hint. Question 7. Right. Okay, go to question 8 now. Question 8. There are identical machines in a workstation. Sound produced by workstation should be reduced by 10 decibels on a POE day. On a POE day. Right? What is the minimum number of machines to be stopped? Minimum number, highlighting again, repeating again. You are asked about the minimum number of machines. Minimum number of machines to be stopped on a POE day compared to normal day. Compared to a normal day. And I'll give you another hint. When it comes to machines, machines are whole numbers, no? Right? Keep that hint in mind. Machines are whole numbers. Right? Which means you can't have 1.2 machines. You can't have 1.5 machines. 1, 2, 3, 4, likewise, it will be a whole number of machines. Give it a try. That is a good question. That is a good question. Question 8. Give it a try. Question 8. Any answers? That's a different question. So think a bit outside the box and try it. Think a bit outside and try it. Question 8. Any answers? There are electrical machines in a workstation. Sound produced by workstation should be reduced by 10 decibels on a per day. What's the minimum number of machines to be stopped on a per day compared to a normal day? See, I'm going to assume this way. Say a normal day is I1. I'm going to assume a normal day as I1. And I'm going to assume a per day as I2. Right, now if I apply delta beta, beta1 minus beta2 equals 10 log base 10 I1 over I2. See what happens now on a normal day compared to a per day, it should be reduced by 10 decibels, which means this difference is 10. I feel 9. Very good. Superb. Yeah, it's 9. It's 9. Very good. Superb. Excellent. That is a good question. That is a very good question. Yeah, it's 9. It's 9. So if you got 9, that is correct. If you got 9, that is correct. Very good. Superb. So this is 10. 10 equals 10 log base 10 I1 over I2. 10 to 10 cancels, which means 1 remains. 1 equals log base 10 I1 over I2. Right, I'm going to subject this. Then you know how to subject this. 10 to the power 1. 10 to the power 1 equals I1 over I2. 10 to the power 1 is 10 no. 10 to the power 1 is 10 no. Then what is coming here? 10 I2 equals I1. What's the meaning? 10 I2 equals I1. What's the meaning? Intensity of a normal day is 10 times of that of a per day. Intensity of normal day is 10 times of that of a per day. No? Then to satisfy this condition, tell me what's the minimum number of machines should be there? Minimum. What's the minimum number of machines? We can't think of the maximum limits because there are more values, multiple values. This satisfies the same condition. But for minimum value, there is only one. What's the minimum number of values to satisfy this? What's the minimum number of machines should be here to satisfy this? What should be the minimum? Right? We can't have such a relationship having one machine because per day, difference between per day and normal day is 10. Right? Then at least it should be a multiplier of 10. Right? You can't follow this relationship having 5 machines, having 6 machines. So therefore, minimum number of machines that you could have is 10. You have to have is 10. If there are 10 machines, minimum is 10. If there are 10 machines, minimum condition is satisfied. Right? Otherwise, this is working for 20 machines, 30, 40, for any multiplier of 10. So that's why I asked about the minimum number. 10 machines. So minimum there should be 10 machines. If there are 10 machines minimum, right? On a per day it is I2. So per day is 1/10 of a normal day now. Which means if there are 10 machines, see, this is the argument, this is the logic hereafter. Therefore, minimum number of machines on a normal day should be 10 to follow this, to satisfy this condition, right? Therefore, minimum number of machines on a per day should be 1. The question is about how many machines to be stopped, right? So therefore, right? So therefore, 9 machines should be stopped. 9 machines should be stopped, right? With a little bit different idea. With a kind of little bit different idea. 9 machines. Good, that one got the answer, correct answer, very good. Right? Minimum number is 10. You can't satisfy this condition with any number below 10 for the total number of machines. That was a thing in the question. That was a thing in the question. That's the thing. Okay, mention these points in red after the question, below the question. Mention these points in red. In red, mention number of machines must be a whole number. Notice number of machines must be a whole number. Write down number of machines must be a whole number. Number of machines must be a whole number. Number of machines must be a whole number. Second point, keep using red. Keep using red. Check whole number values. Check whole number values. Check whole number values. Check whole number values which satisfies. Check whole number values which satisfies check whole number values which satisfies above relationship within brackets 10I2 equals I1. Above relationship within brackets 10I2 equals I1. 10I2 equals I1. 10I2 equals I1. Okay, listen, I'll explain this again. This is a good question. Listen, I'll explain again. Now, I assume a normal day as I1 and a polar day as I2, right? Difference of intensity levels between a normal day and a polar day is 10 decibels, no? So plug that value, and we know for sure higher value is on a normal day, right? This is the higher value. Higher value is on a normal day. So therefore, it should be I1 or I2. With that, after the simplification, you can get a relationship as 10I2 equals I1, right? Check the exact meaning here. I2 is a polar day. Then I1 is a normal day, which means normal day is having a 10 times of intensity compared to a polar day. That's the idea, no? Normal day is having a 10 times of intensity compared to a polar day. Right? 10 times of intensity compared to a polar day. Then, since machines are a whole number, check the minimum value that is possible to satisfy this condition. Now, let's say you had 5 machines. Now, 1 over 10 of 5 is 0.5, which means can you work 0.5 machines on a polar day? No, that is not a whole number, right? So likewise, if you argue the minimum total number of machines that should have to satisfy this condition is 10. If 10 machines are working, to reduce it by 10 times, only one machine is working. Then to reduce by 10 times, when one machine is working, you can stop 9. Right? This satisfies for any value, any value of any multiplier actually. Any multiplier value of 10 hereafter. That is why I asked the minimum value. Now let's say they have 100 machines. If they have 100 machines, only 10 machines are working and 90 should be stopped. Something like that. If they have 20 machines, then 2 machines are working and 18 should be stopped. So likewise, there's no end from the maximum end, but for the minimum end, you can for sure say 10 machines should be there. So that's why the question is nicely given as to minimum value. Is that clear? That's a good question. A different thinking. Okay, go to question 9. Question 9. Try question 9. A person stands 3 meters away from a speaker and hears 120 decibels at this point. Since this sound is painful, because we know 120 is the respective value of threshold of pain, respective intensity level of threshold of pain. Since this value is painful to ear, he walks 27 meters away from a speaker. What's the intensity level the person hears now? Try it. Question 9. Any answers? Any answers before the discussion? Anyone? Anyone? So you were tackling the previous question so good, so well, right? So any answers for now? For this one? Prepare yourself for the practical seminar coming up. Practical seminar means waves practical seminar coming up. Right? Go through all the theory parts we have covered in waves and prepare yourself. So at least any answer, any answer before I start. Anyone? Now, since you were answering all the questions up to question 8 so well, now why not now? Anyone? Simplification is hard for this one. No. If there is hard, probably it might be a wrong simplification, wrong substitution in your case. Right? Otherwise, it's simplifiable. It's totally simplifiable if you do a proper substitution, if you do a proper application. Okay, let's see. 9. Question 9. A person stands 3 meters away from a speaker and hears 120 decibels. Okay, something like this. Now, for your clarity. Now, from this speaker, this person stands 3 meters away, right? From the speaker, 3 meters away, and he hears 120 decibels. So now the person walks 27 meters away from the speaker from this point, and we need beta here, right? Speaker source is here, right? Two different scenarios. Apply a delta beta equation, and now the distance is different. So apply the delta beta equation of distance. 20 log base 10 R2 over R1, right? Beta 1 higher value 120, lesser value beta 20 log base 10, higher distance. So you have to measure the distance all the way from here, from the speaker, right? So that is 30. that is 30. You have to measure the distance all the way from here. Then higher distance is 30 over R1, 3. Right? 30 and 3 means 10. So 120 minus beta equals 20 log base 10, 10. 10 log base 10 is, base 10, 10 is 1. Which means beta equals 100 decibels. 100 decibels. 101. From where that 1 came? Probably your mistake is you have used 27 instead of 30, isn't it? The ones I saw in the chat. Isn't it? You have used 27 instead of 30. Total distance should be put because in the equation there is a distance from source. Distance from source. Now what it says is he moved 27 meters away from that current point, the present point. Then altogether that's 30. Right? Okay, finish. Mention this point below the question in red. Mention this point below the question in red. Mention when distance from when distance from when distance from when distance from sound source increases, when distance from sound source increases, both intensity and intensity level of sound decreases. Both intensity and intensity level of sound decreases. Okay, go to question 10. Question 10. Go to question 10. Go to question 10. So by reading out the question, it's better if you can draw a rough sketch, because in the question there are a few more things given, part of few data are given. There are two sensors, S1 and S2 in a factory. A worker standing 9 meters away from S1. A worker is standing 9 meters away from S1. Right. There are two sensors, S1 and S2. Right. Now let's say one sensor is here. One sensor is here. And this worker stands 9 meters away from this sensor, say S1, from S1. Right. Due to a sudden fire, S1 starts beeping and it produces 110 decibels on worker. So at this point, now it produces 110 decibels. It produces 110 decibels. Right. Now he starts running away from S1, and when he is resting at point B, say this is point A. It should be corrected as a worker is standing 9 meters away from S1 at point A. Right. So I'll label it which as point A. Point A. Right. Now, what's happening? He starts running away from S1, and when he is resting at point B, he hears 90 decibels due to same sensor. Okay. When he is resting at another point, right? We don't know the distance he ran, say X. So when he is resting at this point, B, he hears 90 decibels. 90 decibels. Due to same sensor. Now S2 it starts beeping and it produces 40 decibels on the same worker. S2 is somewhere else. That is somewhere else. Right? Now he is running additional 198 meters to exit the additional 198. Additional 198, which means there's no point of running to the same direction of S1, no? then it should be towards the right direction. See, that you should argue. That you should argue. Now at this point, now this is due to S1. See, this was due to S1. This was also due to S1. Now at the same point, now S2 works. Due to S2, the person here 40 decibels. At the same point, two intensities now. Now he is running additional 198 meters to exit door. Okay, from here, additional 198 to exit door. So exit is somewhere here. Exit is somewhere here, right? Here 80 decibels, right at exit door due to S2. Okay, at exit due to S2, 80 decibels. When the person needs right at exit, like this, right? Which means there is a distance between exit and S2, right? That we don't know. So I'll mark the sensor S2 here, and this distance is unknown. Say y. What is the distance between two sensors? What is the distance between two sensors? Right? If x and y are determined, you can find the distance. Give it a try. 2 minutes. 290. Good. Superb. 290. Good. Very good. Good. Okay, let's see. Okay. Now due to S1, I have two scenarios. No, due to S1 at this point, 110 decibels, and due to same sensor S1, 90 decibels here, right? Which means we can apply the equation of distance. Two scenarios. This is considering S1, no? For S1. V1 minus V2 equals 20 log distance equation, 20 log base 10 R2 over R1, right? Distance equation. V1 minus V2, 110 minus 90, 20 log base 10 R2 higher distance 9 plus x over R1 just 9. This is 20 equals 20 log base 10, 9 plus x over 9, 20 to 20 cancels, 1 remains, which means 1 equals log base 10, 9 plus x over 9. Subject is 10 to the power 1. 10 to the power 1 is 10, no? 10 to the power 1 equals 9 plus x over 9. Simplify this. X equals, this is 90 minus 9, 81 meters. So x is known. X equals 81 meters. X is known. Similarly, you can find y as well. Then finally we can add all of them together. Find y. To find y, I can do the same for S2 due to S2. For S2 due to S2, right? Beta 1 minus beta 2 same equation. 20 log base 10 R2 over R1. R2 over R1. Right? Then 90, sorry, 40 and 80, which means 80 minus 40. 80 minus 40 equals 20 times log base 10 graded distance 198 plus y over y. 198 plus y over y when the person is here. Right? This is 40. So 40 equals 20 log base 10 198 plus y over y. 20 times 2 here. Then 10 to the power 2. 10 to the power 2 equals 198 plus y over y. 100 y equals 198 plus y, which means 99 y equals 198. This is exactly divisible, right? So which means y equals 2 meters. Y equals 2 meters, right? Now the total distance. Therefore, total distance equals 9 plus x 81 plus 198 plus y 2, right? 200 here, 198 plus 2, 200, 281, 290. 290 meters. You can't consider both sensors at once. So consider sensors separately, right? Consider sensors separately. Take it down if you didn't do. Right. So mention this point below the question in red. Mention this point below the question in red. Consider S1 and S2 separately. Consider S1 and S2 separately. Consider S1 and S2 separately when applying equations. Consider S1 and S2 separately when applying equations. Consider S1 and S2 separately when applying equations. Okay, go to question 11. 11. A sound source has a power P. A person stands distance R away from that source hears sound of intensity I. If the distance from sound source is doubled, what is the value of intensity heard due to same source? Okay, give it a try. Now, you should create power because you know E equals eta, right? Intensity is E over TA, right? Now from that create power, and you can get a relationship between intensity and power, and you can use power instead of intensity. I mean, not instead of, you can replace intensity with power if you need to include power in the equation, right? That's a hint. Give it a try. 11. Question 11. Right. The answers. Eleven. A sound source has a power P. Okay. So first thing, how to connect power? How to connect power? You know, intensity is E over T, you know, right? E over T is power, right? We know power is energy over time, which means I can be written as P over A. So simply P equals IA, right? So you can use this equation here onwards as a direct equation also if needed. Power equals IA. P equals IA. Power equals IA, right? Okay, then I'm going to do this. Intensity can be written as power over area. Now, with the distance. Okay, use the delta beta equation. See, now after this, use the delta beta equation. Beta 1 minus beta 2 equals 20 log base 10 R2 over R1. Right? R2 over R1. Wait. If the distance from sound is double, what is the value of intensity heard due to the sound source? Intensity. Okay, then no need to expand, no need to use this equation. Intensity is asked. Use the intensity equation. And nothing is mentioned about intensity level, right? Only the intensity is needed, right? Then there is a direct application of this equation itself. See, there is a direct application of this equation itself. You can use this equation twice. Same source, no? Same source. For scenario, a sound source has a power P, a person stands distance R away from the source. And I told you, now when you write the distance, since sound waves are emitted in a spherical surface, right? Area in ITA equation should be area of the sphere. Area of a sphere. What is area of a sphere? Area of a sphere is 4 pi r squared. Area of a sphere is 4 pi r squared. See, scenario 1, P proportional to I is given, no? Intensity I. A is 4 pi r squared. same source, which means same power. If there is a same source, there is the same power. We need new intensity, let's say I dash. When the person stands, how many meters, how many distance is doubled. If there is doubled, which means there is 4, 5, 2R whole thing squared, right? R2, 2R, R2, 2R, 2R whole thing squared. You can either divide these two equations or equate these two, right? Anything is fine. Divide or equate. I over 4, good. Yeah, it's I over 4. It's I over 4, good. Divide or equate, anything, right? I'm going to divide. I'm going to divide. Then T to T cancels. 4, 5 to 4, 5 cancels. Right? T over P is 1. 1 remains this side. And here I times R squared remains. And from this side, I dash times 2R squared, that is 4R squared remains. Now R squared to R squared also cancels. Subject I dash equals I over 4, final answer, I over 4. Okay, take this down as a note. Take this down as a note. Note power of intensity. Power of intensity. Power of intensity. Right? Write down after the question. So we know E equals eta. Basic equation, general equation equals eta. Right? Create power E over T equals IA. And we know power equals E over T. Right? So therefore, P equals IA. This is the same equation I proved before. Right? For this and highlight the equation and introduce these terms P, I, and A. Right? Introduce terms P, power, P, power, power, I, intensity, A, perpendicular area, A, perpendicular area. Perpendicular area, right? Now, if you are using this for same object, mention this in a red pen, for same object, or same distance, same object or same distance means same area, right? You can also use this equation as P proportional to I, because if A is same, mention that as well using red. Okay, now go to question 12. Go to question 12. Try question 12. Go to question 12. Question 12, any answers? Industry level of a sound source is 80 decibels. When a power 10 milliwatts is emitted, right? If a power of 100 watts is emitted from the same source, determine the corresponding industry level. Any answers? Right. Question 12. 110 decibels. Let's see. Check again. Check again. 120. I don't think. Check again. Others. Other answers. Any answers? This is 120. 120. Let's see. 12. Right. Intensity level of sound source is 80 decibels when a power of 10 milliwatts is emitted. If a power of 100 watts is emitted from the same source, determine the corresponding intensity level. Right. Now we have to connect intensity level with power. Right. For that, I'm going to do a conversion with intensity and power. See, two scenarios are still there. So my choice is delta beta equations. Beta 1 minus beta 2 equals 10 log base 10 I1 over I2. But we know P equals IA. There is the same source, right? Yeah, same source. If same source and same points, areas are same. Therefore, I can rearrange the equation as beta 1 minus beta 2 equals 10 log base 10. So I1 is P1 over A, right? I2 is P2 over same A, right? Then A to A cancels. So what's happening? Beta 1 minus beta 2 equals 10 log base 10, 10 log base 10 P1 over P2. Right. Now I'm going to apply this equation for given two scenarios. 10 milliwatts intensity level of intensity of sound is 80. 80, right? For 10 milliwatts, no? So we know 10 milliwatts is the lesser value, 100 watts is the higher value. So therefore, corresponding higher value should be for 100 watts, that is beta 1, and this is 80, the lesser value 80, right? 80. Then 10 log base 10 P1 100 watts, higher value 100, P2 low value 10 milliwatts, 10 milli is 10 to the power minus 3, right? Beta 1 minus 80 equals here 10 times 10 to the power 3 is 10 to the power minus 2. Take it to here. Yeah, 120 is correct, right? 120 is correct. Take it to here, then there is 10 log base 10, 10 to the power 4. 10 log base 10, 10 to the power 4. Take it to this side, beta 1 minus 80 equals 10 times 4 log base 10, 10. This is 1, right? Beta 1 minus 80 equals 40. Yeah. Beta 1 equals 120 decibels. Beta 1 equals 120 decibels. Right? It's 80 now. I thought it's 30. Right? That's why I told you that 120 is not possible. I thought 30 and the answer is 70. It's 80. Right? If there is 80, 120 decibels. See? So this conversion is the different part here. This conversion, this one. This conversion is a different part here. Conversion. I'm also getting 120. Yeah, it's correct. It's correct. I thought the given value is 30, not 80. Okay. All right, listen. So from here, the entire thing is finished, including theories from A to Z with questions. Right now, since we have few more time, we'll go to past paper questions. We'll try past paper questions, some past paper questions, and we'll wind this off successfully. Right? Then you are also happy that you know what has been come in past papers. No, then you can see that's a definite mark you can get. Try question 1 in past papers. There's a printing mistake there. It should be not 106 times. It should be 10 to the power 6 times. It should be 10 to the power 6 times. make this correction and try question 1. Past papers, question 1. Right? It is not 106, that is 10 to the power 6. Right? It should be the intensity of sound from a source is increased by 10 to the power 6 times its original value. Okay, 10 to the power 6. Try it. What's the answer? So quickly you can do. First one. Past papers, first one. What about it? The intensity of sound from a source is increased by 10 to the power 6 times. Very straightforward. The corresponding increase in sound level. Increase means change. Delta beta equals 10 log base 10 I1 over I2. See how easy these questions are. Right? 10 log base 10. Now if initial value was I, increase value is 10 to the power 6 I to I cancels. Right? So delta beta equals, this is 10 times 10 to the power 6. Take 6 to here, 60. Try question 2. 60, correct. Try question 2. A sound source of intensity I is replaced by a sound intensity by a sound source of intensity 100 I. The change in intensity, same thing. If question 2 is done, go to question 5. If question 2 is done, go to question 5. Good. See how easy these questions are, right? So that's why I said this is one of the most easiest parts you have. So don't miss this mark. This is a definite MCQ. Plus, if it came in, if it comes in the essay parts also, it is coming to like equivalent 4 to 6 marks out of 200, out of 200, 4 to 6 marks. So there will be a bonus if it comes in a comes combined as a combined question with waves, right? Otherwise, we are practicing here for one definite MCQ. We are practicing here for one definite MCQ. Okay, two. Yeah, IN 100 I know. Same thing. Same thing. IN 100 I. Delta beta equals 10 log base 10 I1 over I2. Delta beta equals 10 log base 10 100 I over I to I cancels, right? So we know 10 log base 10 100 can be written as 10 to the power 2. Take it to here 20 decibels. Try question 5. Question 5. 5. A person hears a sound intensity level of 10 decibels when a speaker produces a sound output of 5 watts. Right? Very much similar to the last question I discussed in my questions. Right? When sound output is speaker is increased to 50 watts, sound intensity level that the person here hears is 5. If you have finished 5, go to question 6. If you have finished 5, go to question 6. What about 5? What about 5? So if you can remember the proved equation before, using it directly for MCQ is also totally fine. Now B1 minus B2 equals 10 log base 10 P1 over P2 for one source. Right? I proved this before in the last question. Right? For same source, you can at once use this intensity level that the person here is. Okay, you need beta 1 again, then beta 1 minus 50 equals, 10, beta 1 minus 10, beta 1 minus 10 equals 10 log base 10, 50 over 5. Both are inverts. Yeah, 50 over 5, 10. That is 10, which means beta 1 equals 20 decibels. 20. Correct. 6. What about 6? Question 6. A sound wave of intensity 2 watts per square meter passes normal to a surface area of 10 square centimeters. The amount of energy passes through the area in 1 hour is, what is it? A direct application of 7.2 joules. Let's say a direct application of E equals ida. Right? We need energy. I is given. What's the value? I 2. Time 1 hour. You have to put this in seconds. 1 hour is 3,600 seconds. Area 10 square centimeters. Then 10 to the minus 4. Right? So what's coming? This is 2 and this is 3,600 times this is 10 to the minus 3. Right? Then this 2 to 10 to the minus 3 cancels and 1 remains 72, which means 7.2 joules. 7.2 joules. Right? Then try question 8. 8. Try question 8. Question 8. Question 8. Question 8. Try question 8. And meanwhile, tell me how was the lesson? How was the seminar? Any feedback? Now we have reached the latter part now. How was it? Did you understand the lesson? Or are you now comfortable with the questions? Now I'm showing you the past papers as well. How was it? You can add your feedback as a comment to this video once the live is ended. Right? Otherwise, if you put to the live chat, it will disappear after the live is ended. Right? So therefore, whatever the feedback you have from your side, whether it's positive or negative, right, doesn't matter. You can add it to the video once I end the live. Then add it as a comment, not a chat. Add it as a comment. Then I also can see later whether you have understood or not, or if is there anything that we should improve when we are doing the same in the next time. So likewise, so I also can get some personal evaluation by looking at your feedback. So therefore, it's important. Therefore, So I hope you would add a comment, a feedback comment to the video later, right? So mention whether you understood the lesson and everything. Any answers? All right, question, what did I say? 8. What about 8? 10 persons are standing on a circle. When out of them, it should be when one out of them. Wait. There's a small mistake there. I didn't notice it. It should be, give me 1 second. Question 8. One. It is 1, right? So correct it as 10 persons are standing on a circle when one out of them shouts. The intensity level at center of the circle is 50. If all 10 shouts, the intensity level. Again, 2 different scenarios. We can apply directly beta 1 minus beta 2 equals 10 log base 10 I1 over I2, very straightforward. Beta 1 is the higher value, minus 50, low value, 50, right? Yeah, 50. 10 log base 10. If 10 shouts, 10 I. If 1 shouts, I. I to I cancels. Right? Then beta 1 equals 10 to the power 10 is 1, which means 60 decibels. Okay. Try question 11. 11. Try 11. Question 11. The audio systems A and B produce sounds with intensity levels of 90 decibels and 95 respectively. The corresponding sound intensities are IA and IB. It should be like this. IA and IB should be like this. Typos. IA and IB. IA and IB respectively. The ratio of IB to IA is equal to. Right. Question 11. What about answers? Eleven. Again, 2 scenarios. Simple. 2 scenarios. Right? If 2 scenarios, apply delta beta equations. Beta 1 minus beta 2 equals 10 log base 10 I1 over I2. Right? 95 minus 90. 5. Right? 5 equals, right? 95 minus 90. Yeah? 95 minus 90. Okay. 10 log base 10. What is the higher intensity? 95 and 90. For A and B, IA over IB. IA over IB. Root 10. One says root 10. Right, let's see. 5. So 5 here. 5 equals 10 log base 10 IA over IB. Right. Then this cancels. This is 5 times 2. Okay, take this to the other side. Right, I will do the rest of the simplification here. Half equals, right, half equals half on left hand side, log base 10 IA over IB, right? Then subject IA over IB, whatever it is here, it is coming as a power. Then 10 to the power half equals IA over IB. 10 to the power half means root 10. Root 10 equals IA over IB. Correct. Try 12. Question 12. Try the 12th one. Try the 12th one. So after 12, try 16. After 12, try 16. Twelve. 100. Many document musicians wear special earplugs to protect their hearing during performances. Right? If an earplug decreases the sound intensity level by 20 decibels, it reduces the intensity of sound waves by a factor. Okay, delta beta. Delta beta equals 10 log base 10 I1 over I2. Delta beta is 20. 20 equals 10 log base 10 I1 over I2, right? These two cancels. Then 2 remains. 10 to the power 2 equals I1 over I2, right? Only the factor is asked. So it reduces with the factor 10 to the power 2. 10 to the power 2. Then go to 16. Same thing, by what factor does the sound intensity increase if the sound intensity level increases by 1? 16. More or less the same thing. Delta beta equals 10 log base 10 I1 over I2 1 10 log base 10 I1 over I2. Then divide this, then 0.1 equals log base 10 I1 over I2. 10 to the power 0.1 equals I1 over I2. 10 to the power 0.1. Third answer. Isn't it 2? Isn't it 2? For 16. Try 18. 18. 18. Try 18. An elephant at rest is observed by a person 1 kilometer away from his location, the sound intensity of trumpet of elephant heard by the person is 10 to the minus 10. Okay, with the distance, no, two scenarios are given. When beta 1 minus beta 2 equals distance and wait, only the distance and intensity is given. Then no need to use this equation. Use the equation of intensity. Use the equation of intensity. Right? Equals ita. Or P equals IA. Anything, huh? Again, use kara. I'll just stick to this. P equals IA. Two cases. Same elephant, same power. Initially 10 to the minus 10. When that person is 1 kilometer away, then 4, 5. I'll be doing with kilometers 1 squared. Same elephant. The threshold of hearing is 10 to the minus 12. What's the maximum distance from which he can hear his trumpet? Right, then 10 to the minus 12. We need to find the corresponding distance. Right, let's say R, 4 pi R square. Divide these two. Right, then 10 to the minus 10. 4, 5 equals 10 to the minus 12. 4, 5 R squared. 4, 5 to 4, 5 cancels. 10 to the minus 10 to minus 12 cancels. Minus 2 remains. Right? Take it to the other side. 10 to the power plus 2 equals R squared, which means R equals 10. Now this is coming in kilometers. Huh? This is coming in kilometers. 10 kilometers. Because I didn't convert units, so it is coming in kilometers. Is it 10? 10 kilometers, yeah, good. Then try question 20. 20. 20. Try 20. Okay. 10 identical musical instruments placed along the circumference of a circle produce a sound intensity level of 50 decibels at center of the circle. How many identical musical instruments placed along the circumference are needed to produce the intensity 60? Easy. Very easy. Two instances, beta 1 minus beta 2. 10 log base 10, I1 over I2. 60 and 50, no? Difference is 10. 10 log base 10, let's say number of instruments needed is n, ni of n, right? 10 to 10 cancels. 1 equals log base 10 n subject n equals 10. 10. Right? Yeah, 10. Okay. All right. From the past papers, you can try the other remaining questions as well. See how easy the questions are. Right? Very much easier. Very much easier. That's why I told you this is one of the easiest parts we have throughout our syllabus, not just in waves, throughout our syllabus. All right then. Then yeah, I have finished everything that I was planning to do before the planned time. Now it's 11:40. Yet I planned the seminar until 12:30. But since you were engaging with the questions so well, I could manage it within this time. Now all the content is covered actually. All the content is covered. So I thought of discussing except past papers, right? Except the past papers and letting you do past papers. Now since the time was enough, I discussed you past papers as well, right? Okay then. So that's the end of the seminar of intensity levels. We have discussed from zero, from A to Z, from scratch. If we recall from the beginning what we have done, first you have finished all the theories, and then we started the new questions. Those are not the questions in past papers. We tried our own questions, and then we did some past paper questions as well. Now you have a good idea about okay. Now you have a good idea about how the questions are going to come from intensity levels, right? So this is a very easier part, easier lesson, which don't have any connections with other parts of the, I mean main connections, which don't have any main links with the other parts of waves as well, right? So therefore, here we are practicing for one MCQ. There is a definite one MCQ, right? One MCQ means 1 mark. So there is 1 mark, 1 mark coming, 1 mark you are getting for this intensity levels, right? So I hope all of you are clear about what we discussed today, right? And yes, any questions? Any questions before winding up? Students, any questions before winding up? Is there anything? Is it all good? You feel all good? You feel all clear? So this is how you should spend your vacation in an effective and productive manner. See, just 3 hours, you have completed a lesson with, I didn't count the number of questions, say around 20 questions, right? See how good that is. You have finished, you have started off your vacation with a productive lesson, a productive day, right? So this is how it should be. Try to utilize your vacation like this in other days as well, in other coming up days as well, right? Like this. And from our side also, from my subject, I mean, from my side also, we'll be having especially the wave seminar plus some other question discussions, right? Might be in the mornings or evenings or night times, right? So you better stay connected with the channels and groups, mainly WhatsApp channel and Telegram channel for all common updates. Then you can get to know about the other coming up seminars and pre-discussions and all that. All right then. So if there's no any questions, all good, clear, okay. No, okay, right. So if there's no any questions, we'll wind up. So as I asked you before, it's better if you can add a feedback comment to this video once the live video is live stream is ended. Then I also can see your feedback, your comments in a free time, whether you have got the lesson or not, right? Doesn't matter whether it's a positive or negative feedback. Feel free to add any comment there, because what I need to do is, if there's anything that I should rectify from my end, right, and should improve from my end, I can do the improvements into action in the coming seminars. That's why, right? Okay then. So mention whether you got it, you understood the lesson or not as a comment. Okay then yeah, since no any other questions, I'm going to wind up. All right, then spend your vacation effectively and productively. Mentioning again, saying again, because you have got whole 30 days. 30 days in simply you have got a free month. Free month. Free vacation month. Listen, you have got a free vacation month until December 1st week. So spend it effectively and productively and utilize all time for your work, because you are just 9 months ahead of the exam now. After 25, you are the next batch. You are going to sit the 26 batch. I mean, right? 26 batch. Therefore, don't waste even a minute of time from your time now. Spend it productively and study hard, work hard always. Whatever the effort you put for the thing will give you a grade in return, will give you a result in return. And try to balance all three subjects, right? You have to balance all three subjects, right? Don't have any extreme likes or dislikes. Try to balance all three together. Now, if you feel like you are weak in a particular subject, you are more weak in a particular subject, allocate some more time for that weak subject and try to balance all your subjects, right? Okay, so that's what I need to say from I have to say from my end. So study hard. We'll meet again in another seminar or in the next class, right? All right then. Then goodbye. It's 11:46 yet. Okay, goodbye. See you all again in next class, right? Or next seminar. Goodbye.